Many people who attend the University of Maine may not know that their campus is home to one of the largest offshore wind power development sites in the country. The Advanced Structures and Composites Lab, or the AEWC, works with composite materials to integrate them into civil infrastructure.
They work with a lot of small particles to make materials have more strength properties or have more stiffness properties, with an emphasis on using renewable type of components.
The center is currently developing and testing wind turbines for Maine's offshore wind project and works very closely with the state, the university, and its students.
So the end goal in most, if not all, of our projects is commercialization of technologies, economic development for the state of Maine, and then of course quality research projects for our students.
With Maine relying heavily on oil for its fuel and power sources, the state has enacted what is being called the Maine Plan. Under this plan, the state will get 5 gigawatts of power from offshore wind and 3 gigawatts from other sources of renewable energy by 2020. When completed, the effects will be quite beneficial.
You know, cheaper electricity in the long run. It'll bring costs down. You have all the environmental benefits of offshore wind power. You have thousands of jobs that would be created by a project of this size. It creates jobs in manufacturing, in service.
The Offshore Wind Laboratory is the latest addition to the AEWC and is nearing completion.
The Offshore Wind Laboratory will allow us to design, manufacture, and test full-scale prototypes for blades, towers, spars, and other components for offshore wind structures. So, and really land-based wind structures.
UMaine's Offshore Wind Lab would be the only lab in the world with all those capabilities under one roof. The lab is equipped with a 6.5 million pound wind blade testing fixture that can withstand 50 million foot-pounds of torque, and a 240 foot long structural testing floor, the largest one in the United States, and can accept the weight of a 1 million pound actuator. The lab also includes a dip pit that simulates the ocean's conditions for testing. Center Safety Coordinator and Operations Manager Vernon Darling explains how the dip pit works.
So we would have a 1/50th scale wind generator system floating in the tank, generating scale 12-foot high waves with scale wind, all on that system.
The AEWC hopes to complete the construction of the lab by the end of the spring.